Hello, my name is Haney Sherwood Bastion II. This is going to be my submission for my final project. So for my final project, I wanted to create a file server. I wanted to create a file server that is capable of running independently and running ad nauseum, or whether the client is connected to them or not, such as we did in projects 3 and 4. And projects 3 and 4 is what my project or my final project is based off of. I took what we did in C and used that as a foundation for implementing this code into C++. Now, I wanted to do this because I have a MacBook laptop and I have a Windows OS desktop at home. Putting files in between the two of them can be a little tedious at times. They don't like to play very well, so you have to use third-party systems, and I just want to circumvent that if possible. Now, problems and issues I ran into while tackling this problem is, creating the server and client structure wasn't that terrible. The main challenge was that it took time in learning how to do so in C++ and figuring out how to make the file transferring go well. That was the largest hurdle for me. I ended up using receive, and I had to go ahead and make a function that called receive multiple times in a row and get independent characters and append them to a string and then send that string over. Or rather, take that string in for whenever we were receiving things. Taking the files and putting them into the server storage, that's going to be the directory where the server actually stores whatever it gets, whether it's a text file, a PDF, any of that. Putting the files into there was easy enough, and getting the files copied over was the largest hurdle. It took quite a bit of playing around with receive and creating that function I mentioned, receive line, in order to do so. Now, let's went over that. Things I would like to improve before we go ahead and hop into the code, because I've done this 5 times so far, and hopping into the code is always a long part. Things I want to improve is I want to be able to add a security measure, either dual authentication or a password or something that I will be able to prompt someone who's attempting to connect to the server to give to it in order for it to allow you in to be able to access the information that's served on the server or stored on the server. This is something that started out as a project, but I think I'm going to keep going with it. I kind of named the server. I'm naming it the FireBox because, well, whenever you have sensitive information and papers and whatnot that you want to store and keep safe, you put them in a FireBox. And that's what I want to be able to do with this server. I want it to hold my information, sensitive, not sensitive, regardless of what type it is. I want to be able to store it on there so I can access it wherever I am. Introduce project idea, demonstrate working of your project, implementation of client and server code. Let's go ahead and get on to the code. So I'm going to showcase the receive line real quick, and I'm going to showcase our infinite loop for running the server, and I'm going to talk a little bit about our handling the client before we bump over to the client side. So receive line is going to use receive and get information one character at a time, as you can read right there. And if the connection ever breaks, if receive returns a less than or equal to 0, then it means that there's no more connection with the client. Now, same for if it reaches new line character, it's going to stop at new line because I wanted it to be able to extract line by line by line by line by line. And throughout the code that you can see later on when you're going through this, I actually take and strip off that new line whenever I'm storing stuff, just to make it a little bit easier and a little bit better. Now, I was initially just using receive here and calling it in loops during the code, and that was causing issues. It was storing the contents of the file body into the name of the file in the server directory. It wasn't working well, and that's the part that took me the longest amount of time to figure out and fix. Now, the client, or the server rather, whenever it's initialized, it is going to check and see if server storage exists. If it doesn't, it's going to create that directory. As you can see, we do not have a server storage over here in the folder that has our server in it at the time being. We're going to do all the socket and network jazz that we need to do, and then we're going to run into our indefinite while loop that's going to keep the server running and make threads for each individual client. Now, in our client, and then before I bump over here, we're going to have our handle client function. Our handle client function is going to put us in a loop until the user says exit, and we're going to go through all the commands and do whatever the user would like to over and over and over and over and over again until they hit exit, and then we're going to close that feed. Now, in the client side, I'm already 6 minutes in, so I'm going to be a little bit quicker with my explanations. We are going to have a send line, which is going to send a string to our socket. And then we're going to have our receive line. That's going to be the same receive as is in the server side. The same architecture. We leverage the receive function that's built in to the file systems library and went ahead and expanded upon it. And then we're going to have individual functions for handling push, get, remove. And our main is going to go ahead and connect, create socket, and if connection fails, it will throw an error, and then it's going to put us into a loop, and it's going to tell the users to list, push, get, remove, exit, select an option. Now you have to select options 1, 2, 3, 4, or 5. You can't type in the words, but that's okay. We'll go ahead, initialize the server, and you can see in that upper left-hand corner up here, it went ahead and created server storage. Now we can go ahead and list. We have 2 clients on here at the moment, and we're going to list. Both are showing empty, so we're going to push ex.txt. And whenever that is pushed in there, we can go ahead and check with this client, and we can see example text is popping up. So since example text is popping up, we're going to go ahead and list over here again. We see it. We'll push, and we'll push our AI disclaimer in there. It is not limited to text files. You can do PDFs as well. It's because of the method of transfer. We convert the files into binary and send them in by binary to circumvent any information being lost, and regardless of what type of file it is. If I wanted to, I could even send in server.cpp, and our server.cpp, I selected an option of it. Oops. Push server.cpp, and we can see that we even uploaded server.cpp in there. So say we want to get, say we want to get, and we want to get example.txt. We can download example.txt, and it tags it as d_ex. The d underscore means that it has been downloaded, and it's how you can tell the file apart from other files. And then say we want to remove, we're going to remove example.txt, and then we can check over here, or the other client can see that we have the AI disclaimer and the server.cpp in there. Now, I've also fixed the reader-writer problem by implementing mutexes. I believe that is going to be in the server side, and right here in 3 different functions. In the remove, in the get, and in the push, we have the mutex locks. I use the function lockguard, which automatically, as soon as we exit this area in which it's called, it's going to go ahead and release, so you don't have to lock and unlock it. It takes care of that itself. And you just give it the lock with the file mutex, which is declared up here at the top. And that's all it needs. And then we can hit 5 to exit out. And that's my final project. Have a good summer.